ఇలాంటి చాలా ఉన్నాయి ఇంకా.
Hi everyone. Welcome back to the session. We've been looking at different concepts. We're learning some different concepts with the help of some interesting questions. So this time, as I said in the previous class, this is about transformers. Okay. So we got some simple questions. With the help of those simple questions, the objective is not to solve those simple questions. The objective is to learn from those simple questions. Okay. So don't miss the objective. I think it's clear. We're good to go. Shall we start? I want some heat in the chat so that it'll give some energy for me to start. Yeah. I'm looking at the screen. I'm waiting for your response. Shall we begin the show? Come on, cheer up. Okay. Is there a delay? Okay. That's good. That's good. At least we got some responses. Okay. So quickly, let's roll into the questions. What we're going to see in this session. Okay. So as I said, our objective is to learn from these questions. Okay. Yeah, they are simple questions. If you know the basics strongly, then you can handle tougher questions also. Okay. So that's what we'll try to do with this. We'll build the concepts. That's what the title says. Title of the video says. Okay. Yeah. These are the kind of questions what we're going to see from the transformers. Okay. So now I'm moving to the first one. First question. Back. Here you go. Let's begin the timer. We are beginning the timer. Yep. We start meanwhile. I think do I need to start the timer for this question also? Such an easy one. We already got the answers. Yes, dear, sure. We got a request to make the session on power electronics. We'll do that as well. Okay, so we'll try to do power electronics also. We'll do for everything. See, what we all need is, we need from your end that participation. If you have that little participation, we're pretty good to go. Okay. Anyways, so how come we got a mixed answer for this question also? Some people are voting for B. Huh? How come? Who is voting for B? I mean, the one who is voting for B is not actually looked into the entire question. You got 60 seconds time, right? So why you're in a hurry? Huh? You're not read. You read the question, but you didn't read the options completely. So that is also a problem. See, that led you to do a mistake. Don't do such stupid mistakes. Okay. So it is said a transformer transforms. Like a transformer movie transforms, the body of the car will transform into a robot, right? So is it that here? No. It's a constant frequency device. What's a constant frequency device means? Whatever the input side, transformer is a special circuit, very interesting circuit, which is the heart of alternating system. Yes. What is the heart of an alternating system? Somebody asks you, what you would answer? It's a transformer. Without a transformer, there is no existence of AC. Yes, it's developing AC is not a big deal here, but pumping up the voltage to higher level is a deal. Pumping up the higher level, because of the transformer, AC has won the war of currents. I think you have seen the documentary in our YouTube channel, right? So watch the documentary of AC versus DC, war of currents. So there, the winning factor for AC system over DC is a transformer, because it will make this constant frequency. It will not change the frequency, but it will change the voltage levels as well as it will change the current levels, both. It's not just one. So answer is B and C, which is given as D. That's the answer. So I think we got that. Power is constant, but voltage, yes. Here, another question. Some people will get this point. Yes, absolutely right. Power is also constant. Here, power is also constant. Now, one interesting interview question is, how come in a transform, according to Ohm's law, V is equal to I into R, right? So V is proportional to I is proportional to V. They are directly proportional. But in case of step up transformer, what is that? Step up transformer. Primary voltage and secondary voltage. Tell me relation between V1 and V2. V1, V2. We're heading in something interesting. Greater than or less than or equal to for a step up transformer. For a step up transformer, it is greater than, less than, equal to. What's the answer? Yes? Electrically isolated, magnetically coupled. Absolutely right. I mean, you could say that. Definitely. But that's not a question. It's less than or greater than. Yes, this is this. Careful. We're heading in interesting conclusion here. V1 is less than V2. Now tell me, if you connect some load over here, I1, I2, less than, greater than or equal. Just put the symbol. Just give the symbol. Okay, good. Shiva, I mean, everybody, you guys have rocked it, okay? So this pretty much right. Your team is blasting something, I think, in front of you because you're done, right? So yeah, absolutely. So here, this is this symbol. So now, is a transformer obeying Ohm's law or not? Answer in the chat. Is a transformer obeys Ohm's law or not? Yes or no? Obeys Ohm's law or doesn't obey? Huh? Okay, we are getting answers, crazy answers. It does not obey Ohm's law. That's what you're saying. You're all are wrong. You're wrong. You're wrong. You're wrong. You're wrong. Yes, it does obey Ohm's law. Of course, when you're into non-linear zone, it may not. Let's take it in linear zone. Let's consider this is in linear zone. Flux is not saturated. At this relation is valid, pretty much valid. So how come you're saying it is not obeying Ohm's law means? This is what a common confusion which everybody has. You're thinking that a simple question. We're just talking about transformation, voltage and current. We know that, but you don't know the details of it. That's what we're trying to do. We're trying to build the concepts. Focus, pay attention. You don't have to get into the tougher questions to build the concepts. These easy questions only will tell you how good you are at the concepts. Okay, and interviews, if they ask such a simple question, that's it, you're gone, you're trapped. Okay, and we have done a video also. Let me just give you a gist of the video. So your objective of saying it does not obey Ohm's law is pretty much straightforward. Here, voltage is higher, current is lower. So according to Ohm's law, voltage increases means current should increase. That's your logic. That's not my logic. Okay, that's what Ohm's law says. Voltage increases, current increases. Current should increase, provided resistance is constant. Yes. V is proportional to I or I is proportional to V, you would say, provided resistance is constant. That's what Ohm's law. If resistance also changes, suppose, according to Ohm's law, current will also change naturally. Okay. So here, V2 increasing, I2 decreasing, don't see that way. As somebody has rightly said, it's not about temperature and all, dear. No, somebody has rightly said, I think, who is that somebody? Yes. Sai Krishna has fantastically said, it's actually two different circuits. This is a different circuit. This is a different circuit. There are two independent circuits. That's what the beauty of the transformer. Two independent electrical isolated circuits. Okay. So here some voltage, higher voltage is there here. Here suppose 500 volts is there. Careful with this point. Suppose on the secondary side, tell me 500 volts and the load resistance is, let's take it as 100 ohm. What's the current? What's the current here? Tell me. What's the current on the secondary side? Yes, I want to hear from you. This is V2. This is RL. What is I2? What is I2? Yes, what is I2? Temperature is not the reason here. That somebody is saying temperature will not be constant. That's not the reason. Okay. I'm giving the reason. Just wait. So I2 is equal to, what's I2? I'm asking a question for I2. Absolutely, that's a simple one, right? So I2 is equal to 500 by 100. Tell me, why did you do this? Is this not Ohm's law? I is equal to V by R. Is this not Ohm's law? I2. Yes, this is Ohm's law. V by R, which is 5 ampere. Now, let us take input side voltage is 100 volts. Input side you got 100 volts. Now tell me, what's the value of current at the input side? What's the value of current at the input side? I think for you to say this, you have to transform this load resistance onto the primary side. Tell me now, what's the value of load resistance when you refer this to primary? When you're referring the same resistance, when you're treating the same resistance onto the primary side, what's the number? Obviously, V2 is 500, ideal transform, let's take for the sake of simplicity. Ideal transform, V2 is 500, V1 is 100. So what's the N value? N1 by N2 value, ratio N1 is to N2 is how much? Simply 1 is to 5. N1 is to N2 is simply 1 is to 5. Okay, now tell me. Sir, some gate questions on the transformer cold flux is proportional to square of the load current. R is load, but transformer is a constant flux device, right? We'll come to that transformer thing. What about this RL dash? Yeah. So RL dash is simply 100 into, we got 1 by 5 whole square, which is 25, which is equal to 4. Yes, right? Now tell me, if the resistance referred to the primary side is 4 ohms, okay, this 5 square actually, it should be square, right? So what's the current now here? I1 is equal to how much? Tell me. What's the value of I1? What's the value of I1? I1. 25 amperes. Tell me, how you got this 25 amperes? How you got this 25 amperes? Did you use Ohm's law or not? Huh? This 100 by this 4, which is 25 amperes. Ohm's law. Now what about this? Power, 500 into 5, 2500. 100 into 25, 2500. Power is constant. Did you not use Ohm's law? You did use Ohm's law. So it pretty much obeys Ohm's law. There are two independent circuits here. These are two independent circuits. Okay, so you're applying Ohm's law here, you're applying Ohm's law here. I think you got the clarity. Ohm's law is pretty much valid. Don't say no in an interview. If you say no in an interview for this question, bang, you're gone. Okay. Anyways, I think you got a clarity on this. If you have something to ask on this, you can ask. So meanwhile, let me answer Roger's question. So in some gate question, transformer core flux is proportional to the square of the load current in our load, but transformer is a constant flux device. Just send me that question. I think there may be some misunderstanding. You must have misread the question maybe. Just WhatsApp as a question. You know the number, right? 99899399982. Or else in the description you will have the link. Just click that and send that question. We'll see the question and we'll see that. Definitely transformer is a constant flux. Constant flux, it does not mean that it's steady flux. It's a time varying flux. But the peak to peak values which are constant, that's what you're trying to say at steady state. Okay. To increase the right current, you need to increase the flux, blah, 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 blah. I think we're all set. We're good to go to the next question. I think this is clear. Back. Now, let me run the timer as well. So start doing this, start doing this, start doing this, start doing this. Did you learn something from the previous question? Everybody knows the answer, but everybody doesn't know the inside the details of this, right? So knowing the answer is not key aspect here. Understanding the details is also key aspect. Wow, it's good. I think everyone marked it correct. Okay, so ready to blast. We are ready to blast something over here. Yes, good. So everyone answered correct. Okay, good. Keep it up. Come on, it's a simple one, right? A transformer. What's the answer by the way? 2. Ideal transform is the one which has a common core of its primary and secondary windings. That is true. The statement is true. That is true even for practical transformer, also not necessarily for ideal transformer. Okay, the statement is true, but this is not answering the question. No losses and no magnetic leakage. Yes, this is what addressing the question. Let's look at the further options as well. Core of stainless steel and windings are of pure copper. What's this? No, I mean windings are of pure copper even for your practical transformer as well. Interleaved primary and secondary winding, is this true or not? Only for one case. For which type of core this statement is true? Interleaved primary and secondary windings, this statement is true, but for a specific type of core of a transformer, what's the core of the transformer? Yeah, answer. So what's the core of the transformer? Where interleaved? See, Nagdeep, what happened, Nagdeep? Shell type. Sandwich winding is for what then? Sandwich winding is for what? Sandwich winding is for what? Concentric winding, interleaved winding, concentric winding, it's for core type. Sandwich, which is for shell type. Okay, I think you got a clarity on that. We move to the next one. So this statement is true for a specific type of transformer, not for everything, but it's a statement, not for ideal transformer, to be more precise. For ideal transformer, yes, this is the only option which is a match for this. Okay. Next one. I think this is also easy, you can do that. Got confused? Yeah, you should not get confused, man. Come on. Huh? You got confused means you're not so solid with the concepts. So these simple questions will help you to build the concepts. Okay. Mixed options again. How come you got the mixed options for this? Huh? Mostly D are saying, but except Lokesh, everybody said D. I think maybe some confusion. I think Lokesh might have got confused on something. We can still give it a go. Okay, so pretty much good, guys. I mean, you really participated very nicely. Okay, keep it up. Nice. Okay, good answers, except one. I think maybe Lokesh must have misinterpreted this. Okay, anyways, good one to go. Let me go to the solution. The main purpose of use of core. You need a core to place a winding. So basically the purpose, one of the purposes is to hold the windings, to support the windings. Should be mechanically strong. It should be mechanical. strong. And the main purpose is not that. Main purpose is to reduce the reluctance. In case of a transformer, there is no air gap. There is no air gap between two circuits, primary circuit and secondary circuit. Okay. Now, to reduce the reluctance of this, we'll place the core. Now tell me, we use which steel? There is a special steel we'll use for this transformer core. Tell me what is that steel, what is used for transformer core. I want from everybody. What is the steel name? Which steel? Not just regular steel or stainless steel, whatever. So there is a special steel. What is that? Lokesh, again. What happened, Lokesh? Huh? You missed it. I think you got confused, I think maybe. Good, everyone else has marked it good. Okay, it's okay. You don't have to delete your answer. It's okay. It happens. Okay. It's a CRGO steel. Now tell me. Same, if it is a transformer, I'm using a CRGO steel. If it is induction machine, both are similar, right? Transformer and induction machine, they are similar. And rotating transformer, you would call if it is induction machine, right? Is transformer, can we call a transformer as rotating transformer, induction machine as rotating transformer? Yes or no? Amorphous core, that's for different purposes. For a high frequency and all, we will use that amorphous core. Yes, true. So if it is induction machine is called as rotating transformer, tell me what is the material used for core of induction machine. They are also steel. What is that steel? Here also laminated, by the way. Laminated CRGO steel here as well. So Emmanuel has said a rocking answer. He said laminated silicon steel. Absolutely right. It's laminated silicon steel. Now the question is, if they are similar except the rotation, why you're using silicon steel in case of induction? Why you're using CRGO steel in case of a transformer? That's a task for you. You do that task. Interesting exercise. We normally discuss these kind of details in our course. Okay. You just try to watch the free videos from the app. You'll get some basic idea. Okay. Free videos are available in the app. Download the app. Access the free videos. Access the free test. Then you will learn these basics much better. Okay. It's not because of the air gap. It's not because of the permeability. It's not because of anything else. You can't even expect that. The name itself says. So anyways, do the research. You will understand that part. So the main purpose is decreasing the reluctance of the common magnetic circuit. That's what the main purpose of the core. The secondary purpose is mechanical support. All these things are the secondary purposes. The main purpose is reducing the reluctance. Okay. So that's the answer. I think for this also, you can pretty much easily answer this. Easy one. Go. Kritish. He's back for a long time, I think. No, variable frequency, how does it matter? If it is a variable frequency, how does it matter? That is an interesting answer, which I think no one has answered for that. CRGO, by the way, silicon steel sofa. You just search it, you will get it. Okay. See, this is how we should learn the things. Not just knowing the answer. If it is a machine subject, power system subject, you have to know each and every detail. Nowadays, come on, yaar, everything is available. Information era you're in right now. So everything is available. Wow. This question also everybody answered. Everybody answered correct for this question as well. Good to see. Well within time you marked it. Good. Blaster? Okay, blaster is also done. Blaster bhi ho gaya. Transformer core is laminated in order to, careful here. They will sometime ask a question in a different way. First, for this specific question, It says transformer, core, or laminate. Just talking about laminations. Just talking about laminations. The laminations are done to minimize the eddy current losses. Yes. Now sometimes the question would be, why we are using a laminated silicon steel? The purpose of using laminated silicon steel, if that is a question, then the answer would be definitely eddy current losses. If hysteresis is also there, that is also right. Okay, so both B and C would be right. If the question is about laminations, he's asking about laminations, he's asking about silicon or maybe CRGO steel or steel. Why you're using a material steel? That is also a question. Okay, one of the reasons of using steel is to reduce the hysteresis losses. Okay, so you need to keep that point in your head. So we got a couple of things. Where is, yes, CRNGO. Okay, so Rohit is saying non-oriented. Okay, CRNGO, non-oriented steel. Okay, cold rolling is a process actually. Cold rolling, hot rolling. There are two processes of rollings, cold rolling and hot rolling. Anyways, you can see those things on the web. It's pretty much informative thing, but it's a point which you need to focus on. Silicon reduces electrical conductivity. Absolutely, Shiva, you're right. I think you must have visited the sessions of PiSquare. Then you're saying it. Good, keep it up. Induction motor rotor frequency is less. So what? What about the stator frequency? Stator frequency is fixed, right? Stator frequency is still Fs. Why you're not using CRGO steel over there? Why you're using silicon steel? So that's not the answer, by the way. Anyways, we are clear with this. Moving on to the next. I think this, without doing much of math, you can answer this. Yes, you're right. Alternator stator is silicon steel. The question is why? Why not CRGO steel? That's a question actually. No answers on this. If you want to use calci, you can. But tentative answer, if you're smart enough, I think 1 minute is pretty much good for you to answer this. 2400, but there is no option, Emmanuel. Huh? So option E, Emmanuel option is E. 1600. Lokesh, I think you should give the option, not the value, so that whatever a team is pulling up, they're displaying the poll options, right? That will be there. Good. Alien boy. I think in some place, aliens, Morocco somewhere, aliens are found. Alien mummy is found, I think. Okay. So Ashok Kumar is saying B, but Mexico. Okay. But good. Pretty much good. Everybody answered correct. Everyone marked A for this. So it's a good call. I'm happy for that. So let's see. A transform is having now. Another common factor between one common factor between DC machines and transformer. What is that common factor between DC machines and transformer? Huh? Yes. N1 by N2 is equal to E1 by E2. Of course, in case of a DC machine, N was a speed, but here N is number of turns. Though there is a difference, but equation is pretty much similar, right? N1 by N2 is equal to EB1 by EB2 or EG1 by EG2 if it is a DC machine. If it's a transformer, this is the equation. It is pretty much, all machines are pretty much similar. You have to know that, that's it. Okay, all machines are pretty much similar. Anyways, coming back, So N1 is given as 1000. This is 1000. N2 is unknown. E1. See here, is this E1 or V1? That's also another confusion with the guys. Tell me, is this V1 or E1? Is this supply what you're giving? Is this E1 or V1? Yes, absolutely. This is a V1. So it is nothing said. So we'll take that liberty to consider this one as E1. So it is 250, but to be more precise, it is V1. Okay. Now this is 400. Now, pretty simple. Secondary side higher voltage compared to primary side. So number of turns will be high in secondary. So if primary is 1000, secondary cannot be these two. Ruled out. Now, secondary voltage is more than 1.5 times. Check it this. 250 definitely more than 1.5 times. 400 is more than 1.5 times. So N2 also definitely more than 1.5 times, not this. So this is the only option. It's not a fill in the blank. Be smart in answering such MCQ questions. Because you're not having a calculator, don't waste your time on doing the math. Of course, it's easy math. You can cancel out this, here with 4, and this with here, 4, 16, 1600, and 2 is equal to 1600. That's good. A simple math. But I appreciate if you use your aptitude skills on doing such MCQ questions. Okay, that's how your quant aptitude skills will be handy. Okay, I think you just got, of course, the answer, but a smart way of attacking these questions in a less time. People ask this thing, how to manage the speed and accuracy. Okay, so for these, make advantage of these MCQs, huh? Okay, I think this is also easy one, which you can answer. Go, try now. See, Raju, the objective is to not to have these easy questions, because you learned a lot of things in the easy questions, right? I'm not just giving you the answer, question, answer, question, answer, question, answer. I'm not doing that. I'm giving other details. You're building up the concepts. I ask a couple of questions, you fail to answer it. Okay, so first build the basics. Once you build the basics, then definitely it will be good. And yes, you should not expect these easy questions in the exams, but you should know you're not even knowing such easy questions answers also. Then what? What if tough questions arrive? Huh? Time's up. So we got only one person is saying D, almost 7 people are saying A, so we can pretty much give it up. An ideal transformer has a no load primary current of I0, okay, and which is definitely, careful with this. This is a key point here again. Any current is there. It is said ideal transformer means purely inductive nature of the winding. Purely inductive nature, because there is no resistance, it is an ideal transformer. So voltage, if I take this as a voltage, you are giving it a pure inductor. Of course, it's a coupled inductor. It's a coupled inductor. Now tell me, is this a symbol of a transformer or something is missing? Tell me, is this a symbol of a transformer? Something is missing. Something is missing. What is that something is missing? Huh? Tell me. Raju, you tell me. Is this a symbol? What is missing? Ha! 2 lines are missing. cannot say that they are missing. Yes, this is a transformer symbol, but this is air core transformer symbol, not the transformer what we use in power levels. This is an air core transformer. Now this one is a magnetic core transformer. So these two lines are also having a significance. Those two lines will signify that there is a magnetic core which is common between these two windings. That's why in case of when you're drawing induction machine equivalent circuit, you will not draw these two lines. You know why you'll not draw these two lines? Because there is air in between connecting rotor and the stator. So you should not draw that. If you're drawing, that's wrong. Okay, it's not a common magnetic field. Okay, anyways, so this is V1 and that's pretty much straightforward. Current flowing through a pure inductor will always lag this voltage by 90 degrees. And of course, it is said ideal transformer means this current will be very less current. Okay, so that less current itself is generating a flux. So this is the answer. Lags behind V1 by 90 degrees. Somebody is saying leading, Emmanuel said, I think leading V1 by 90 degrees. I think you must have misinterpreted. And we got another video on phasor diagram. If you're having any kind of confusion on phasor diagram, either download the app. In the app, you will find the phasor diagram free video, or on YouTube, just search phasor diagram PiSquare Academy. You'll get amazing video with lovely animations. Absolutely. Okay. Without animations, I don't think we'll ever do such a beautiful concept. Okay. So you will love that. And if you watch that phasor diagram video for any kind of subject, irrespective of subject, you will be able to just like that do the phasor diagram for any kind of equation for sure. Okay, it's not my thing, it's not I'm saying it, I'm just forwarding or diverting people's comment. People do comment after watching that video like that, so I'm just forwarding that to you. So it's your call. If you want to watch, you can watch, otherwise go to hell. Okay, anyways, this is next question. Go ahead and try to answer this. Good. We got answers, almost everybody said correct. Okay, nice, keep it up. But some mixed answers also there. Cool. The primary, secondary induced EMFs E1, E2 in a two-winding transformer are always E1, E2, they're always in phase. Yeah, in phase with each other. C is correct. Almost everybody marked it wrong. Come on. What's this? No, you're wrong, dear. How come you're saying B? It is about induced EMFs E1, E2. Induced EMFs E1, E2, they are in phase with each other. What's wrong with you all? What happened? This is not quite expected, guys. You guys are saying it's easy questions, but yet you're able to not answer these easy questions also. So, what about a bad scene? Huh? Not quite good. What to do? Let's go ahead to the next question. Okay, we cannot keep waiting for this. Yeah, it's not, you didn't do well, but yeah. Okay, at least this one, this is again easy one. Pretty well. Wow. You guys are all charged up. We're getting back-to-back answers correctly. Okay. Almost everyone answered correct. 8 people. have marked their answers. 9. I really like this interface which my team has designed. They're giving the voting system and all. I mean, pretty much amazing. My team is superb. Good. Everyone marked it right. Everyone. 11 votes. All 11 are correct. That's good. Okay. Great. Great to see that. Come on, it's easy one. That's why you answered it. What's great in this? Huh? Step up transformer increases. Step up transformers increases power, increases frequency. Bullshit. Wrong. Okay. It's a constant. These two are constant. Step up current is down. This step up, step down terminology with reference to voltage, not with reference to current. There are different classifications of transformers, different classification, different categories on basis which we'll classify the transformers. So based on voltage levels, step up means it is increasing the voltage. Easy one, that's what you answered. I was like so happy to see all of your answers, but I just realized it's easy one, that's why we marked it. But anyways, easy or tough, deal is a deal. You marked it good. Power is same, frequency is same, your analysis is also same. Very good. Current will decrease. Very good. Yes. I think now I'm literally realizing my team is underpaid here. I'm realizing they designed a lot of softwares. They designed their own softwares. According to my requirement, they're designing the softwares and they're giving the interface. I could see everything right now on my front. Thank you, man. I always be amazed with my team. Anyways, time's up. Uh, so we got a 5 for A, 2 for B, 2 for C. Okay. Let's get in. The voltage. Oh, for this question, you're giving wrong answers. For this question. And you wanted tough questions. For these easy questions, also you're doing wrong. What will you do if I give you tough questions? Huh? First, be confident. Don't forget about easy or tough. You ask me for tough questions only if you can answer all the questions what I given in this session. Okay. Then you are eligible to ask for tough questions. Okay. The voltage transformation ratio of a transformer is voltage transformation ratio. The name itself is a transformation. How much voltage is transformed? How much voltage is transformed? So with reference to the secondary side, they are asking transformation ratio. How much is transferred? So E2 by E1. Or it's okay if you call it as N2 by N1. Okay, now look at this. Secondary induced EMF by primary induced EMF. Yes, it is about the induced EMFs, not the voltage, the supply voltage and load voltage. Secondary voltage, primary voltage, wrong. On the nameplate of a transformer, the voltage values are given. Those voltage values are E1, E2. This is also one of the interview questions. Okay, they're not V1, V2. They are E1, E2. Clear? So this is wrong. Primary turns to secondary turns, they're trying to say N1 by N2. That's the turns ratio, N, not a transformation ratio. Wrong. Secondary current by primary current, which is nothing but N1 by N2, which is N turns ratio. So this is also wrong. So secondary induced EMF by primary induced EMF. This is right. How come you guys are doing this? Yes. For the PiSquare team, I think for my team, I'm really proud of my team. Now even I'm even more proud to see this. They are doing animations. I trouble them a lot. I must say this. I give all stupid instructions to them. I want this, I want that, I want this. I'll give crazy thoughts. Okay. Did you ever see live sessions anywhere in the world as interactive as in this fashion at least? Forget about lectures and all. Tell me about the interface. The blast and all. Yesterday I saw the broadcast. I myself saw the broadcast, previous live session. I was like, it's good. They're controlling in a nice way. It's like, movie set. You know. Anyways, I think नजर लग जाएगा मेरे टीम को नजर लग जाएगा किसी को मत बोलना ऐसा ठीक है छोड़ो नेक्स्ट मूविंग ऑन टू द नेक्स्ट क्वेश्चन bang I think my team they themselves created not less than 12 softwares. They write the code for for requirements to meet the requirement. They themselves write the code. Okay. Yeah, with emojis. Yes, absolutely. I mean, that's really crazy. Okay. ठीक है ज़्यादा नज़र मत लगाओ मेरा 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 टीम को ठीक है बस तुम लोग एंजॉय करो you guys take advantage of it okay we are here to offer did you see that animations have you ever seen those animations what you see at the beginning of the video anywhere control systems what name the subject man will bring the things into your imagination will come into reality what's a PiSquare tagline everyone give in the chat what's the tagline for PiSquare tagline huh how many of you know at least I want to see how many of you know PiSquare tagline PiSquare logo obviously PiSquare logo tagline not just that I want a full tagline bridge the gap that's true but I want a next further bridge the gap after that there is something more right what about this too there is something with this too as well huh what's that so you guys even don't know that that's crazy all of you you're just enjoying the sessions like anything and you're not knowing yes bridging the gap with multiplied effort square 2 times effort we are keeping more effort bridging the gap means the logo itself says you are here there is a person on top of this that's you okay you are this guy and there is a ramp on the ramp we are here to take you from here to here with multiplied effort with lovely 3D animations okay so we're always doing that we always do that in future okay there are many reasons of keeping this logo and all anyways we'll talk about this logo if we talk about this logo itself I think we'll have to spend 1 hour of time in the discussions we will talk in some other time for now look at this the primary and secondary windings of an ordinary 2-winding transformer always have different number of turns is this correct different number of turns nobody answered it's not necessarily there are transformers with 1:1 ratio also tell me the name of the transformer there is a special name for which we'll call it as 1:1 transformer what is the name of the transformer tell me name of the transformer huh yes isolation transformer the purpose itself is isolation purpose which is used in your power electronics laboratory for sure now you may ask a question 1:1 there is no step up there is no step down why do we have to use a transformer to isolate electrical isolation which is pretty much important in power electronics okay so yes this is wrong people would answer this usually that's wrong actually same size of copper wire why if it is a different ratio It can have different size. So there is no rule that it has to be same size. Common magnetic circuits, definitely yes. Definitely yes. Separate magnetic circuit, no. Both primary and secondary are having same magnetic circuit. Okay. Same magnetic circuit. Isolation transform used in UPS nowadays, absolutely. Okay. Let's go to the next question then. I think this is also easy one which you can make it. Let's see. Mahesh is asking something. First, did you took yourself to any destiny or else only lecturing without any rank in gate or selections? You're asking me. Oh, means you don't know anything about PiSquare, huh? You don't know anything about PiSquare, you don't know anything about me, and you don't know about my rank and all. First, do search that. You will get it. AR0, not AR1, much less than that. Okay. Hey, come on, Tritish. You don't have to say my gold medal and all. He will find it out. Why do you need my rank? Why do you need my gold medal? My gold medal, my rank, do you think it will give anything? My lecture will give you. So enjoy the lecture. You will be stunned, you will be stopped, you will be, your mouth will be zipped up. Okay. Anyways. Okay, it's okay. It's your choice. If you don't want to know, don't know. Absolutely. Gold medal will, if you just mug up, you will get a gold medal. I don't, I'm not great because of my gold medal. I'm great because of my lovely tea. Okay. So do one thing, who is that? Mahesh. Go to the first of this live, starting first 1 minute you watch, you enjoy, have a good time. Anyways, time's up. We got some interesting cover-up story now. Okay. Guys, chill. Let's come back to this mood. I really like this guy. Okay. Mahesh Kumar Sharma. Thanks for joining, for entertaining us for at least this short time. Okay. Anyways, in two winding transformers, the EMF per turn, EMF per turn. I mean, just now we have seen this equation. I mean, we have seen, right? E1 by N1 is equal to, is that right? Yeah, E2 by N2. So this is EMF per turn, which is same, which is equal for both primary and secondary. Two winding transform, the EMF per turn in secondary winding is always same, always same, always same. Okay, so it's equal. It's equal. Okay, I think everyone answered. Come on, yeah. How can you say option A and option B? Huh? You guys are crazy, huh? It is about not E1 by E2. If it is E1 by E2, you would say it is 1 by K, where K is a transformation ratio. It is about EMF per turn. See? So C is answer. Okay. So, good. Let's head to the next question then. Okay, I really like this guy too much. See this comment, okay? Oh, I think we'll catch you up sometime. Deleted his. हाँ मेरे को हिंदी नहीं आता ठीक है So guys, I must say this. Raju is saying this. If electrical engineering is a temple, Sekhar sir is priest. And Sekhar sir is priest, that's true. Sekhar sir is not the only priest. Sekhar sir is one of the priests. there are a lot more amazing priests, guys. I know in this COVID, I don't know how much it helped you. There is a positive side also of this COVID. There are a lot of faculty has come up on YouTube. They are giving amazing lectures on YouTube. I really loved that aspect. Okay, that happened just because of the COVID. Okay, that's a positive side, you must say. I mean, I'm enjoying Mahesh company. Okay, I don't know you whether you're enjoying or not. I'm enjoying Mahesh company. Okay, in relation to a transformer, the ratio 20 is to 1 indicates that ratio 20 is to 1, because normally we give a transformer ratio as n is to 1. Okay, so what does it indicate? That's what the question. There are 20 turns on a primary and 1 turn on secondary. 2 votes. Wrong. It's not 20 is to 1 does not mean that 20 turns and 1 turn. It might be 200 turns and 10 turns. It might be 400 turns and 20 turns. It could be anything. Okay. So the ratio is 20 is to 1. Okay. So primary voltage, secondary voltage, primary current, secondary, for every 20 turns on primary, there is 1 turn on the secondary side. Absolutely right. It's a ratio. And we just got 2 answers for this. Raju is team member. No, you are from team member. You are the team member. Mahesh Kumar Sharma is our team member. He is here to entertain us. So I'm glad he's back. Okay. I saw you there. Anyways, leave it. Enough of entertainment. Let's get back to seriousness. Okay. So look at this. Try to handle this. You know why I'm engaging you? Because I'm getting entertained. It's just a matter of minute to block you, but I'm not blocking because I'm enjoying your company. Okay. Disturbing? Come on, yaar. I'm at least enjoying. If you guys are saying disturbing, I should block him. I will do that. Uh, okay. Let's not be harsh on him. At least for today. Bangla, Akshita Paul, কি করছে? বলতে পারবে আস্তে আস্তে। Bang. Time's up. Time's up. Compared to the secondary of the loaded step-up transformer, the primary has, compared to the secondary of the loaded step-up transformer, okay? So whenever you get a transformer, you know, the circuits, drawing circuits will be a lot more helpful, okay? So try to draw the circuits, then visual clarity will be there. The way PiSquare animation is giving, why animations will be helpful for you? Because you'll get a visual clarity, okay, 3D animations, which nobody ever does. We are doing that to get a visual clarity. The same clarity, you try to keep it on a paper by drawing this. Now it is a step-up transformer, good. The primary has definitely lower voltage than secondary. It's about the current, okay. So primary has low voltage, hence high current, okay, lower voltage and higher currents. So option is A for this, okay. Next one. Yes, Madhuteja. I think he had to see the starting of the video. Let him feel. You know, these are all PiSquare team members. Those whoever is including you. You're also PiSquare team member. So let's blast for Mahesh. Yeah, Mahesh, this is for you. Enjoy. Thanks for entertaining us. Bang. Time's up. Transformer cores are built from laminations rather than from solid steel. I think, come on, easy one. Any wrong answers? Everybody answer mark, correct? To reduce the eddy current losses. Now let me add another question here. There is one more way of reducing. Somebody answered actually in the chat in the previous question. What's the other way of reducing eddy currents apart from lamination? There is one more way. What is that way? What is that way? Yep. I'm asking you, what's the other way of reducing the laminations? I just want one word. It's a simple thing. You're absolutely right. Shiva has said absolutely silicon steel. Steel is not a concern. Silicon is a concern. Adding a silicons to the steel will bring the conductivity down. That's what you said, I think. So conductivity down means eddy current losses will be down because current is down. Okay. So good point. So you got 5 more questions. I think this is also easy one. Quickly, let's wrap it up. Try to answer this. Adding silicon will reduce the conductivity of the core. Okay. Good. Others? Cyclist is asking strength of silicon, strength of CRGO versus silicon. Just, that CRGO silicon, you just Google it, you will get a better idea, much better information. Don't stop guessing it. Search it. That's a task, right? So do the task. Okay, I think for this question, everybody answered correct. See. Let's talk about this voltage regulation concept a little bit deeper, because voltage regulation of a transformer, synchronous machine, power systems, all are having same voltage regulation. Okay, you have to, whenever you see this term voltage regulation, you have to keep this curve in your head. This has to struck in your head. Exactly this shape, this thing should struck, and here ZPF lagging, and this one is ZPF leading, and this is UPF. So try to keep this in your head, then you'll be able to answer 60% of the questions on voltage regulation. And if you can have the numbers, at what value this will be maximum, at what value it will be 0, and at 0 what's the magnitude of this, what's the maximum magnitude of this, this is per unit resistance, this is per unit impedance. Okay, so at what value it is 0, at what power factor it is maximum, if you can fill this figure promptly, you'll be able to answer 80% of the questions on voltage regulation in transformers, be it synchronous machines, be it power systems, be it anything. Okay, so that's what the beauty of this curve. Now it is asking about where this will be 0, when this will be 0. This will be 0 during leading side, negative leading side. Okay, negative power factor means what? A no load power factor is, no load voltage is less compared to the full load voltage. Okay, full load voltage is higher. That's what you will see in case of Poplar effect in transmission lines, Faraday effect. Okay. Anyways, there are a lot of other aspects in this. Okay. So that's about this question. And what's a power factor? Can somebody tell me what's a power factor at which this is maximum? Power factor this is maximum. And power factor this is minimum, which is 0. Just give that figures. Try. You have to have these things in your head all the time almost. Anyways, I'm moving on to the next. One. Time up. Okay, time's up. I think we pretty much got a mixed answers for this. It's okay. A primary reason why. Now guys, I strongly recommend you to watch two videos today. Number one, PiSquare Academy phasor diagram video. That's one thing. The second thing is OC test. PiSquare Academy, search on YouTube, get the result, watch that. Okay, or else we'll try to add that links in the description of this video after the end of the live. I'll try to add it. So there you got something else, some other interesting answers why we have to go for why we should connect open circuit is performed on the low voltage side, why it is so clearly, not the textbook one, the practical reasons I have explained there. Okay, so you must definitely watch it, which nobody ever said so far on YouTube. Okay, that's the first one we said that. And we done a lot of such things. Why 50 hertz, why 11 kV and all. You'll never get anywhere before our video. Our video is the first video, okay, with that proper reason. And there is it becomes controversial as well. 11K video has become a lot of controversial. Anyways, that's a different story. Yeah, so this is requires least voltage to perform the test. This is answer. Okay, this is answer, not about the power. Power will be the same whether you connect on primary side, secondary side, I mean low voltage side, high voltage side. No load power is pretty much same. Okay, there won't be any difference in the power. It involves less core losses. If power is same, core loss is also same. Okay, so drawing large no load current for the convenient reading, people would consider this one as answer. In the textbooks, people will say this, but that's not the primary reason. Okay, prime reason is this. You can check that video and you get the practical insights of that. Next one. This is also easy one. I think you will answer it. I think Mahesh, we lost our buddy to entertain us. If he's there, he would have entertained a little more, but oh, we missed him. Lokesh is saying Mahesh is iron loss. We need that loss, man. It's good sometimes, not all the time. Shunt parameter. 5 seconds. Wow, good. I think only one person has said B, everybody said C. It's closely correct. So, no load test is for magnetizing current, knowing the magnetizing current. You'll find I naught definitely. You'll find cos phi naught. So from there you can find out I mu, you can find out IW or IC. You can find out all these from the no load test. Thereby you can find out RM or RC, core loss resistance. Thereby you can find out XM. So these are the parameters which we are trying to find out, and obviously the wattmeter reading no load power also you can find out that. Okay, so magnetizing current and no load losses, that's what you're going to find out from that. Okay, efficiency cannot really find out from no load test, but no load test will be helpful to find out efficiency. Okay, the way I said, exams, your subject may not give this particular subject, machines may not give directly the job, but by keeping the job, cracking the gate or any exam in your head, you can bring this machine subject in your hand. Okay, so that's what I always say for my students. At least when you are attempting any exam when you're attempting, you make sure that you mastered two new subjects. Suppose you are attempting one exam in this month maybe, so try to master two subjects. Maybe after 6 months you might be attempting another exam. There make sure that you master two more subjects. Okay, no partial mastering. You think there is a word called partial mastering, that's a shit. There is no word called partial mastering. Okay, either if you want to master, you have to master it fully. What's a partial thing here? There is nothing partial. Okay, anyways, make sure you will master two things at least, two subjects at least. So similarly, efficiency, for finding out efficiency, no load test will be helpful, but no load test is not enough for efficiency. We just got two more questions. Let's get up quickly. I think we missed the number somewhere. Maybe it's okay. But we try to reduce the iron loss. That's why we don't have to reduce iron losses. That iron loss is already lost by himself. Okay. See, he's still entertaining us, though he's not there. How come you got mixed answers for this also? Let me see the question. Time's up, by the way. During short circuit tests, the iron losses of a transformer is negligible because flux produced is small fraction of the normal flux. Definitely you are giving same frequency, rated frequency, but the input voltage is less, so the flux is less. If the flux itself is less, the eddy current losses and the hysteresis losses, they are related to flux. The flux itself is less, so naturally the losses will be less. Okay, iron losses will be less. So iron losses will be less because of the flux produced is small. So 50-50, that's not actually quite expected for this question. Okay, so 4 people are saying A, 4 people are saying B. How come you're saying A? The entire input is just sufficient to meet the copper loss only. Not sufficient, you're not limiting anything. You are giving current is, it will take current. It's not a constant current source, you're feeding a constant power source. Constant voltage you're feeding, reduced value. It can take any amount of current it wants. It requires. Okay, so I don't know on what basis you marked for A, that base also is wrong. Okay, conceptual itself is wrong. Anyways, Next one. Voltage required is less for rated current, so V is less. Iron loss is less. Yeah, V is less, flux is less, hence iron loss is less. You're right. Power factor is not constant. Okay. Time's up, I think. Timer is not running. Okay. Transformer here on this also, we got I think a 15 minutes video on this. Search this one also. Okay, or we'll try to add that in the description. Y series, I strongly recommend all of you to watch our Y series playlist. Okay, there in that Y series, not just this why it is in kVA, why your air conditioner is in tons. It's an electrical device, you will call it as a ton, 1 ton AC, 2 ton AC. Why is it so? Okay, so there are a lot of things which you have to know. Okay, so BC is true, total transformer losses depends on volt ampere. Load power factor is often not known. This is answer. You cannot say this is answer for this. Okay, volt ampere, this statement is true. There is no denial for this statement. Total transformer loss depends on volt ampere. That's true. No denial on that. That's not the reason why we kept this. We keep this because of this. kVA is fixed, whereas kW is, yeah, this is also true. Load power factor is not often known, true. kVA is fixed, whereas kW depends on load power factor, true, definitely true. A, B is right answers rather than B and C. Induction machine also, yes. Losses are there in induction machine, there, they still it is in kW, right? You're right, Madhuteja. So I think once you know our details, at least in the PiSquare app, we described all these details with a clear information. So statement wise, this is a true statement. But for this, answer is these two. So it could be MSQ. Okay. Or else you can even say this is more appropriate because this statement is within this. Okay, this statement is within this. So you can say if you had to only choose one option, I prefer choosing option B because option A is also within this. Option B has a little more information. Okay, so I would prefer option B if I had to select only one. If I had to select multiple, A and B would be the right call. Okay, so we got one more. We got one more. Let's finish up this also. The last one. Okay, not so bad. Time's up. The equal size transformers parallel operation is, of course, next level concept. We have to have an idea of this parallel operation because this will be helpful for all machines. Okay, right from DC. We call it as transformer, you call it as asynchronous machines. Parallel operation is there. Okay, it's like buy one get three options. So you should not miss such concepts. Two equally sized transformers A and B are connected in parallel. Impedance of A is more than impedance of B. So always remember, impedance is high, so current is low. So power is low. Parallel operation means voltage is same, it's I current. Voltage is same because they're in parallel. Voltage is same as impedance is high, current is low, hence the power is low. Okay. Of course, you name it as apparent power. Okay, it's okay if you call it as active power also. It's a simple concept. So A is having more impedance, so A will supply less power. A will supply less power. No, not equal. That's why we'll make sure that impedances, to be more precise, per unit impedances should be same. Okay. So this is also wrong. B will supply more than A. Yeah, that's true. So that's end of this amazing session. So you all, including Mahesh, we had a blast today. Okay, so we're blasting already. Anyways, that's about today's session. It's good to see all of your participation. And my recommendation is phase diagram concepts, Y series videos. These, we have to have an idea of these things. Okay, so try to watch them. We'll update them in the description of this video. So which will help you to master some of the basic fundamental concepts. Because if someone asks in an interview, so why you're having AC in ton, ACs are in ton, why you're having it? If it's an interview, basic interview question, common sense question. So you should be able to answer it. So Sai Krishna was asking another thing. When can we expect TSGENCO notification, sir? If there is a first of all, tell me, dear Sai Krishna, if notification is released tomorrow, in 60 days, if exam is ready, exam date is in 60 days, are you ready for the exam? Tell me in the comment, how many of you ready? If TSGENCO exam is in 2 months, just 60 days time you have, are you guys ready? How many of you are ready? You're not ready. Then first get that preparedness. So get that preparedness, then wait for the notification. You're not even ready, you're expecting the notification. Yes. If it releases in October first week, just to answer the question I'm saying, yes, notification we are expecting. We're all expecting, like you are expecting, in the first week of October. Okay. It's good that institutions or coaching institutions like us, we are anticipating for notification. That's a different purpose, because there we need to serve the students over there. But for you guys, first of all, you get that readiness. Once you are having that readiness, then expect for notification. At least you're not even ready for 30% of the marks right now. 30% of subjects also you're not confident. Then how come if it comes tonight, you can't bag it? So stop worrying on that, buddy. Okay. So it's my humble request to all of you. Before expecting any notification, answer yourself how much I'm ready. You're ready at least 30%, start expecting the notification. At least 30%. But that 30% of the subjects, 100% you should make that 30%, 100% confident on that 30%. Okay. So then yes, hope for the notification. Once the notification is released, remaining 70%, you can finish it up. Okay. So yeah, that's not for Sai Krishna, everyone. So go to that extent, because now it's 2023. Content is amazing content, not just content. Amazing content is available on internet. Okay, and yesterday my team has said, I think one channel they shared, what's that? RLC Education. Nikhil sir, I think. Okay, he's I mean, I loved that guy. Okay. He went to RTI as per my team, he went to RTI to know the notification details, how many vacancies are there, all these details. He has done an amazing job. Okay. But you guys, sir, he put a lot of information over there in his channel about the notification and all. And you're not happy with that. Again, you're after questioning not just one person I'm talking to. I'm talking to everyone who is anticipating for the notifications without actually getting ready for the notification. Okay. So my request is get ready for the notification, then anticipate for it. Okay. That's the only thing I must say for everyone. With this, I'm ending this beautiful session. Thank you all. Have a good time. And anything more?